Let's take a look at problem 3a. I want to begin by looking at the domain and the range of the function, and then we'll move on to identifying the equation in standard form. So let's get some definitions. The domain of a function is all possible x values. More specific and exact way to put this would be that it's all possible inputs. But just to simplify it a little bit, we're going to go with all possible x values, but just know that if your function had, let's say, like, instead of being an x here, it was a p, then it would be all possible p values. But let's just stick with x just to keep things simple for now. And the range would be all possible y values. A better way to put this would be all possible outputs that correspond to an x value, but let's just leave it as all possible y values for now. All right, so the domain of a function is all possible x values, so this parabola looks like I can have any x value in it, so this is going to be all numbers. Another way to put this that mathematicians like to say is all real numbers. And if that looks like a pain to write out and you're curious, this symbol is the symbol mathematicians like to use to say all real numbers. So if you write that down, I will know what you mean, and you're just saying all real numbers or all possible x values. The range, however, is not going to be all real numbers because this parabola has a minimum value. This parabola can never go below -3. There's no possible way for that to happen. So it looks like there are some y values which are not possible. However, it does not have a maximum because it is always increasing. So the range will be y is greater than or equal to -3. The answer would not be y is greater than 3 because y can equal 3. This is a little bit hard to write on a computer. So the way you could write that would be y is greater than, and then you write an equal to sign, and then you write -3. This is the same thing as writing this if you write it on a computer. If you get them mixed up and write this, I'll know what you mean, but that kind of looks like an arrow to me, so I prefer to use this one. Now let's get to the fun part, finding the equation of this parabola in standard form. On the quiz, you all did an amazing job finding the vertex form of this equation. However, this parabola, we want to find it in standard form specifically. The vertex form and the standard form are very different things. So we're actually going to be using your vertex method to find the standard form, however, so it's really awesome that you all know how to do that. So the first thing we're going to do is we're going to identify whether this function is easier to write in vertex form or intercept form. If it's easier to write in intercept form, the roots will be obvious, and if it's easier to write in vertex form, the vertex will be obvious. These roots are kind of hard to see, but however, this vertex is really clear. It's at the point 2, -3. If we remember, vertex form is y equals a times x minus h squared plus k, where the vertex is hk. If this is the vertex, that means h is 2 and k is -3. So let's plug that in. We get y equals a times x minus 2 squared minus 3. Now we need to figure out a. A is the vertical stretch or shrink. So let's just compare this parabola to how a parabola normally goes. If we were to graph x squared, it would go over, when we go over 1, the first time we go up 1 from the vertex. So if this has been stretched or shrunk, it will not go over, it'll not go up 1 when we go over 1. However, when we go over 1, we go up 1, which means there is no stretch or shrink. So that means a is 1. So our equation is y equals x minus 2 squared minus 3. Okay, so this is the vertex form. However, we need to find it in standard form. Luckily, it's very easy to find standard form from any of the other forms. The way I'm going to do that is I'm going to distribute. So this is going to be, this is equivalent to y equals x minus 2 times x minus 2 minus 3. Remember, the square means that it's x minus 2 multiplied by itself. So this is another way to write it. And then I'm going to do some foiling, which is an acronym to use it. But really, it's distributing. It's multiplying every number with every other number. So this will give me x times x is x squared, x times negative 2 is minus 2x, and then I get another minus 2x, and then negative 2 times negative 2 is plus 4, and then minus 3. Combining like terms gets me y equals x squared minus 4x plus 1. And that's my final answer. That's the equation of this parabola in standard form. So we used the vertex form you figured out, and all we had to do that was left was the next step was to convert it into standard form. Let's look at the domain and range of parabola B. So here we say that the domain is all the possible x values. Every parabola will have a domain of all x values, which I can say all real numbers because I like to say it that way, but if you say all x values, that will also work. The range is going to be a little bit trickier. The range refers to y values. If we look down here, there are a bunch of y values that this parabola cannot equal. This parabola has a minimum at the point 1, negative 1. So that means that y is greater than or equal to negative 1 because there are no values less than negative 1. So this would be our range. Y is greater than or equal to negative 1. Once again, a reminder, on a computer, you would write greater than sign and then an equals and then negative 1. This is the same thing. Once again, let's do the fun stuff. What is the equation of this parabola in standard form? Step 1, identify whether this parabola is easier to write in vertex form or intercept form. Well, this parabola has no roots, so it's going to be pretty tricky to write it in intercept form. So let's go with vertex form. Luckily, the vertex is really easy to find. It's at the point negative 1, 1. If you remember vertex form, it is y equals a times x minus h squared plus k, which hk is the vertex. This tells me that h is negative 1 and k is 1. So I can plug that in and get y equals a times x minus negative 1. Oop, computer glitched out. X minus 1 squared plus 1, which will be y equals a times x plus 1 squared plus 1. Now we need to find a. So last time I did it by identifying going over 1 and up 1. I want to show you how to do it algebraically. Let's take the point 0, 2, and I'm going to plug in 2 equals a times 0 plus 1 squared plus 1. So I just took another value on this parabola and I substituted it in, another point on this parabola to substitute in. This will give me 2 equals a times 1 squared plus 1. 1 squared is 1, 1 times a is just a, so 2 equals a plus 1. If I subtract 1 from both sides, I get a equals 1, which is what we would expect because when we go over 1, we go up 1, which is the standard change when you move away 1 from the vertex of parabolas. Of course, it isn't always going to go up 1 when you go over 1. It's going to increase the rate of change, but parabolas, if they don't have a stretch or shrink, will go over 1 and then up 1. So our equation in vertex form is y equals x plus 1 squared plus 1. Now we just need to convert that to standard form. And standard form is always going to be y equals ax squared plus bx plus c. So the way I would do this is first, I'm going to rewrite x plus 1 squared as x plus 1 times x plus 1. And then, of course, I still have plus 1. I'm going to FOIL this. So x times x is x squared. X times 1 is x. 1 times x is x. And then 1 times 1 is 1. And then I still have this plus 1. This will become x squared plus 2x plus 2. And of course, it's an equation, so I still have my y. Y equals x squared plus 2x plus 2 is my answer in standard form.